Welcome to Wikipedia for Sleep. Tonight, we gently explore the struct in C programming. Allow your body to soften, your mind to unwind, and your eyes to slowly close. Introduction. In the C programming language, struct, referring to a structure, is the keyword used to define a composite, aka record data type, a named set of values that occupy a block of memory. It allows for the different values to be accessed via a single identifier, often a pointer. A struct can contain other data types, so it is used for mixed data type records. For example, a bank customer struct might contain fields for the customer's name, address, telephone number, and balance. A struct occupies a contiguous block of memory, usually delimited, sized by word length boundaries. It corresponds to the similarly named feature available in some assemblers for Intel processors. Being a block of contiguous memory, each field within a struct is located at a certain fixed offset from the start. The sizeof operator results in the number of bytes needed to store a particular struct, just as it does for a primitive data type. The alignment of particular fields in the struct, with respect to word boundaries, is implementation-specific and may include padding. Modern compilers typically support the #pragma_pack directive, which sets the size in bytes for alignment. The C-struct feature was derived from the same named concept in ALGOL 68. Declaration. The following simple example depicts declaring a struct named myStruct, with two fields of types type 1 and type 2, respectively. The added name myStruct is optional in some contexts. Members may possibly be padded for memory alignment, and thus it is often recommended to order fields from largest to smallest size for efficient memory usage. A function may directly return a struct, although this is often not efficient at runtime. Since C99, a struct may also end with a flexible array member. Structs can be composed of other structs. It is legal to declare an anonymous struct within a struct, but it cannot be named in C, as there is no notion of nested types, unlike C++ where nesting named structs is legal. A struct containing a pointer to a struct of its own type is commonly used to build linked data structures. Circularly referencing between two structs must be done using a forward declaration and pointers. Typedef. Via the keyword typedef, a struct type can be referenced without using the struct keyword. However, some programming style guides advise against this, claiming that it can obfuscate the type. For example, in C++ code, the type may be referred to as either struct thing or thing, without any need for typedef. Typedef in C++ is also superseded by the using statement, which can alias types that have templates. Initialization. Considering the struct declaration, there are three ways to initialize a structure. C89 style initializers are used when contiguous members may be given. For example, for non-contiguous or out-of-order members list, the designated initializer style introduced in C99 may be used. For example, if an initializer is given or if the object is statically allocated, omitted elements are initialized to 0. A third way of initializing a structure is to copy the value of an existing object of the same type. For example, copy the state of a struct can be copied to another instance. A compiler might use memcpy to copy the bytes of the memory block. Bit fields. Structs may also use bit fields to allow fields to share the same storage units, but layouts are implementation defined. Pointers can be used to refer to a struct by its address. This is useful for passing a struct to a function to avoid the overhead of copying the struct. The operator dereferences the pointer left operand and accesses the value of a struct member right operand. Functions may take a struct as a parameter by value, but this is expensive as it copies the entire struct. Meanwhile, passing it by pointer is often preferable as the size of a pointer is known, typically 4 or 8 bytes. In other languages, Crystal programming language, D, Go, Julia, Rust, Swift, and Zig have structs. C++ and C++. Struct is essentially the same as for C, but also with methods. Further, a class is the same as a struct but with different default visibility. Class members are private by default, whereas struct members are public by default. NET languages have a feature similar to struct in C, called struct in C# and structure in Visual Basic. NET. This construct provides many features of a class, but acts as a value type instead of a reference type. For example, when passing a NET struct to a function, the value is copied so that changes to the input parameter do not affect the value passed in. See also bit field, data structure that maps one or more adjacent bits, flexible array member. See language feature passive data structure. Another term for record union type, data type that allows for values that are one of multiple different data types. That is all for tonight. Let the silence settle in. Sleep well.